Alright guys, we're starting out with chapter 6, looking at bones and bone tissue. This exam will cover 6, 7, and 8. That's a lot of material. It's like a 130 question exam, so there are lots of labeling. But I'll go over what your labeling is later. You do want to know some of the functions of the bone, so the shape will kind of predict what its function is, as well as the support. So we use this to hold us up, so we won't be some big lump mass of tissue laying in a chair. Protection, particularly our flat bones, help for protection. So if you're thinking about real sensitive, important organs, heart and lungs sitting back behind this thoracic cage, these flat bones are big time protectors. So we've got ribs, sternum, and then if you look at the cranium, those are also considered flat bones. They protect something very vital, the brain. So those are for protection.
Does the red bone marrow, is that like...
We'll get to that. Movement, your long bones are the big movers. So these are going to be your humerus, your femurs, tibias, fibulas, things like that. Those are all movement. Another pretty cool thing about your flat bones, not only are they for protection, but these scapulas back here, these are not really protecting anything because we have the thoracic cage. But your flat bones are also really large and have what are called processes, little bumps or pokey out things of the bones. Those allow for attachment of muscle. So when you see a really large flat bone, that means you're going to have some big muscles around that area. So think about the back muscles, and then you even have some of the arm muscles here. Another good example of those big flat bones is this pelvis. We've got really large gluteal muscles that are attached there. So you got to have something big to allow for that attachment. Let's say electrolyte balance. So we have calcium and phosphorus that is taken out of the bones and put into the blood, and it goes the other way as well. So when we've got too much calcium, then we put it back in the bones and we'll build some bone. Blood production, that's where our bone marrow comes into play, and we'll look at bone marrow specifically in a minute. Acid-base balance, we have the release of acid that will go into the blood and we'll change it. We'll change the concentration of our blood, make it more alkaline or acidic, depending on what the needs are. We'd have different classes of bones. So we talked a little bit about flat bones and how they're used to protect organs, the brain, heart, lungs. We don't really have anything here protecting those abdominal walls. When we get into the digestive system, we'll talk about how we use things to protect it. Long bones, mainly for movement. Long bones, again, we can have some very large muscles. We talked about flat bones having that large surface for attachment of muscles, but even your long bones, think about the quadriceps that you have. You have that are sitting at femur. That's what that big process right there is for, to attach those big muscles. So if you see any big things that are sticking out, then that's probably going to mean we've got some big, huge muscles. Short bones, you'll find in your wrist and your ankles. So those can withstand, a little bit of weight. It allows for a lot more movement, and they'll roll over each other. So that's why they're shaped the way they are. Irregular bones, you have lots of those in the face, as well as the vertebrae. And we're going to talk more about those irregular bones in just a minute when we're talking about red bone marrow again. You have to know all these parts, and I'll actually have you label those. So you've got to know all of those. So the diaphysis, the middle part of your bone, it's what you would think of the shaft. It's very dense tissue. It's strong, extremely strong. So if you had a break in the femur here, it would be a lot of pressure to be able to get a break in that femur. When you have little ones, young children or babies that have broken their femur, the first thing that your primary care physician is going to be suspicious of is child abuse. because it's really hard to break a femur. You would have to grab that kid by the leg and throw them to break a femur. It can withstand a lot of pressure. Now, ways that people do break femurs, especially kids, trampolines. That's one thing. They can get tangled up in them, and when they do and they flop backwards, that can break that femur. But it has to take a lot of pressure. So again, if they are broke, then they're going to think, what happened with that? In these long bones, in our medullary cavity, we have bone marrow. Like I said, we'll talk about bone marrow in a minute and talk about what is contained in that bone marrow, and what kind of bone marrow, and what it does. Periosteum wrapped around the long bone, and that is where blood vessels and things can attach, especially tendons can attach there. Or ligaments, ligaments can attach and burrow into that periosteum. So that's how they hang on to the bone. The very ends of your bone, your epiphysis, made up of some compact bone. We're going to look at its matrix in a little bit. And then on the top of that, you'll have some articulate cartilage. The main thing that's for, when we get into joints in Chapter 8, we'll talk more about articulate cartilage. But that's to create a smooth surface when those two bones are rubbing up against each other. So if you have this tibia and this femur, we would have articulate cartilage in between there, and they would roll across each other. So it would be nice and smooth, not rough, causing pain.
Please rotate to your next section. USA members, please rotate to the next section.
Another thing about the periosteum that I need to mention before moving on, it also contains bone-forming cells in the periosteum. We're going to talk about bone growth in just a minute, because we will grow in length until a certain age, and you need to know that, about 16 to 24. So normally girls 16, 17, where boys can grow into their early 20s still in height.
Stop growing?
Yes, height. But now bones in diameter around them can continue to grow all throughout your life. So depending on what you're doing, they can decrease. So if you're not doing a lot of weight-bearing exercises, they will decrease in size, the density around it.
Will they break easier that way?
They will break easier. So as you increase weight-bearing exercises, they will build up around it. So the diameter around it will get bigger. So we do have bone-forming cells and blood vessels in that periosteum, that lining around it. So we can grow this way, but we're not going to grow this way after a certain age. So weight-bearing exercises, since I mentioned that, what are some weight-bearing exercises?
Running?
Running is weight-bearing exercise.
Stretching?
It's your body. Stretching, some, they talk about yoga, things like that. That is a weight-bearing, weightlifting, anything. What isn't a weight-bearing exercise?
Sleeping.
Swimming. Exercise would not be considered or sleeping would not be considered an exercise. Swimming and bicycling. Those things are not really considered weight-bearing. It's just something as simple as walking is weight-bearing. And that's what you need to know when you're instructing especially your elderly, your older population about osteoporosis, and they need to do weight-bearing exercise, because this compact bone, this around it, gets kind of porous and starts to look like this. And that's not good. And so it does break easy. Okay, we need to talk about the epiphysis. You can see a little line through here, and that is called your epiphyseal plate. That's when, like your age, probably not my girls, but my guys' age, your epiphyseal, it's still called an epiphyseal plate. That means that it's still active and growing in length. Where my girls are probably 16 and above in here, you have what's called an epiphyseal line. So it's now replaced those chondriocytes. You got to know that chondriocytes are cartilage. Chondriocytes mean cartilage. These chondriocytes are replaced with osteocytes. So now they're bone. They're calcified. So you have a line. where our guys have an epiphyseal plate. It's still cartilage and it's still growing. Yes?
So is it possible for like you might be possible to get taller?
Not really. Nope. Your girls, they normally quit growing pretty quickly. Let's see. So, that's how when they're looking at skeletons that they found, they're trying to determine age. They'll measure the femur and they'll compare it to the average length of that femur, what age group that falls in. And they'll even look at that line. So if they have an epiphyseal line, that means they've stopped growing. So they've got to be above, say, age 25. They'll know that. They'll say, well, this was a white male that was above the age of 25. Or they'll say 25 to 30, 25 to 45. And they'll know, as far as male-wise, they'll look at the pelvis. And they can measure the opening of the pelvis, how large it is. Women's are kind of more flat and flailed out because they need to be able to open and move. And then they can look at the skull, the facial bones, to determine, well, are they Caucasian? Are they African American? What were they? So the study osteology of the bones is pretty interesting. Okay, we'll talk about bone marrow. I don't want to get into it just yet. I think I've got it coming up. Did I already cover that? Yeah. Which of the following are functions of the bone? So what does the bone do?
There's more than one, isn't there? C and B.
So there is more. So which of the following are functions of the bone? Yeah. All of them except for one.
Except for D.
Except for D. That's the only one. We don't have anything to do with glucose in the bone. So yes, electrolyte balance. So we can take calcium and phosphorus and put it in the blood, and we can remove it. It can go back and forth. Blood production because of the bone marrow, and then acid-base balance. Yep, we can exchange salts and make that pH change. So all those.
It's so weird talking about this stuff because that's like happening like right now.
Now this stuff is happening in your body. So you need to know the different types of bone tissue or the cells and what they're doing. So your osteoblast, I like to say B for build because they help to build your bones. They get bigger and bigger. So osteoblast, where osteoclast, they tear down the bone. So you need to know, and this is usually a difficult concept for you guys, if your calcium levels were really high in the blood, who would be active? Because if you, blast. It would be osteoblast would become active. Because what they're going to do is they're going to remove that high level of calcium in the blood and put it in the bone. Because we don't need that much calcium. It's like, oh, well, we got a proliferate or a high level of calcium. Let's build bone then. So that's why drinking milk will help build bone. Now, when those levels drop really low, your osteoclast will say, oh gosh, if your calcium levels are low, that's bad. Bad for muscle contraction, and if we're talking about muscle, we're talking about heart muscle particularly.
So what bone are they going to start dissolving?
What bone?
Yeah, like it's unwanted bone. What's an unwanted bone?
It'll start to take away from that the diameter of your long bones. It'll start to eat away at that.
Okay.
Yeah. So that's why they do want you, especially our women, because we leach a lot of calcium. They want you to take, they may have you on calcium replacement, but that's why they're saying you need to drink milk, and so that you don't get into low levels and start tearing down your calcium and tearing down those bones. So class will eat away. Now osteocytes, these are very mature and they're actually embedded within the bones. So they do both of these jobs. Osteocytes are your bone cells, but now they're sitting in the bone. They're not moving around. They're not building and tearing down. They're sitting in there and they will build and tear down both. They do both of those jobs. They do both jobs of osteoblast and clast inside the bone itself. Osteocytes, so they'll regulate blood levels of calcium and phosphorus. You gotta know that. They'll regulate blood levels of calcium and phosphorus. What makes bone very unique, because it is a connective tissue, we talked about connective tissue being blood. It can be even tissue far as your fascia, wrapping around muscle, that's connective tissue. But bones are connective tissue too. The thing is it's a lot different than everybody else because of its matrix. Matrix means what builds it up, what makes it. What is it made of? Well, it's made of really hard bone. And that's what makes it unique, is its hardness. How extremely hard it is. You do need to know in your book, I think it's page 86, and I don't think I have it on my slides here. No. You do need to know the different types of strengths that your bone has. So one of them is called a tensile strength, and that's actually taking the bone and stretching it long ways. So taking this bone and being able to stretch it, that's tensile strength, and it's collagen. When you think collagen, you think kind of a rubbery, collagen's what's under your skin, fills it, makes it no wrinkles and looks nice, keeps your top skin connected to what tissue's underneath so it doesn't slip. So when people get older and they start to kind of sag and then they get the wrinkles, it's because of the lack of collagen. It's very elastic. So for the bones to be able to be pulled on, so someone pulls your arm, it's not going to break because of that pull. It have to be a high, lots of pressure to pull. So that's tensile strength, and it's collagen. Tensile, I kind of think of like a rubber band. Tensile strength, or tinsel that you put on your Christmas tree. You can kind of stretch it. The second one is your compressional strength. So taking that bone, you jumping, that puts pressure and compresses the bones down. That's calcium salts that prevents it from breaking when you just jump. When you're doing lots of jumps or something, that's putting compression on those long bones. Calcium salts prevent from that. The last one is torsional strength. Problem with torsional strength, we don't have very much. Torsional strength is the same when you take and you twist that arm. So that's another good example of one of those. If we see a type of break that's called a spiral break. So that's when parents get really angry and they grab their child and they yank them up. And if there's a twisting or of the bone, a spiral break, they'll be suspicious of child abuse with that as well. So we don't have a lot of strength for that torsional strength. So we don't have a lot of that. So it will break. Yes, Jason?
Did that happen when the police officers, if people are resisting arrest and they...
You usually don't see it in adults. You usually don't see it in adults. I mean, it'd have to be a lot of pressure, but arm bars and stuff like that, yeah.
So what is that whenever, I've heard of babies having it where, if you move them a certain way, even, not even hard, their bones will, pop out, socket?
Yeah. They are very, especially at birth, their ligaments are very loose, and so they can make it through those canals, and they can twist and change. So yeah, they can pop in and out. Yeah. You got to be careful with them.
I died that happened. I would think. It's so sad.
Okay, so let's look at, let me go back to that picture because I want to talk about the two different types of bones that we have in our long bone. So, very strong, just like it sounds. Here in the middle, the diaphysis is all made up of what's called compact bone. It's really strong. Whereas spongy bone is found at the ends. Spongy bone, though, is strong as well. You think of compact bone being the strongest, and it is pretty strong, but talking about those different strengths that we have, how it can break under those, spongy bone is really strong. And the reason it is this trabecula. this formation here, how this looks like a sponge, like a household sponge, but that actually increases strength. So why would we find this type of bone at the ends of our long bones? Yes?
Because like you're like stepping maybe,
Uh-huh.
you're like putting pressure on them.
Because when I'm jumping, it's these ends that are absorbing all that pressure when I'm jumping up and down. Those are what's feeling all the pressure, not really the diaphysis.
And the only time the diaphysis is really good if you're like laying down on it, right? Or like doing like push-ups.
Yeah, if you end up pushing on it. But again, this will absorb most of the weight, and then it will be distributed throughout. But yeah, that's why those joints are filled with that spongy bone. Hee hee hee. But on the outside of spongy bone, you still have compact bone. So wrapped around, even at the ends, we have some compact bone. What else do I need? So allowing for lots of strength in that structure. You do need to know a little bit about compact bone structure. So spongy was the turbulate, looks like a sponge. Compact bone, everything's compacted inside. So you have all these osteons, which are the bone cells, the structural unit of this compact bone. They're all packed in there pretty closely. And you want to know two different types of canals. Hervatian, so they're running, like it says, like it says, they're running up and down, Hervatian canals. And then we have a transverse Volkmann's canal running this way. And those are carrying blood. They got blood vessels in them. So that's how we're getting blood to those those bone cells. What is the basic structural unit of the bone? So what is the bone? The basic, very structure unit.
A.
And that's what we just talked about. We talked about it with compact bone, but yeah, your osteon, structural unit. Your osteocyte is just the bone cell. So the unit would be an osteon. You got to know that. Yay, we finally made it to blood or bone marrow. Okay, so
Bone marrow like give protection a lot more like in that area. If
No.
the bone has bone marrow, is it stronger?
that's not what it's for.
Okay.
But it is very important. Oh, that keeps tracking
Produces blood cells.
way over there. Yes. Come on. It's tracking weird. So bone marrow, yes. Now, if this was a young child, say below 2, there would be all throughout, you would see red bone marrow in these bones. This is what mine and your skeleton looks like. Most of your red bone marrow is in your flat, so these flat bones and in the skull, and then your irregular bones, which would be vertebrae, and then the facial bones. That's where you'll find red bone marrow.
I think my hips
You
are
won't
just
find
bigger
it
than that.
everywhere else.
She said, I think my hips are just a little bit.
So, red bone marrow, like it sounds, makes red blood cells. Or makes blood cells itself.
What about the head? Why is the head the same color? Like, is that where?
Yeah, that's
All the
flat
hairs
bone.
where the-
That's flat bone and irregular bone.
Okay.
So, what does yellow bone marrow do? What does it look like?
Hello?
It's yellow, but what does it do? What's it for? It doesn't make fat, but it stores fat. Yeah. So, in these long bones, that's where you're going to find all this yellow bone marrow. So, the majority of our body, the bone marrow is going to be filled with yellow. Now, if you get very ill and sick, we can convert yellow bone marrow back to red bone marrow. And so your skeleton, if you were sick, like have cancer, this would convert over to red bone marrow so that you'd make lots of red blood cells to help out. Intramembranous ossification. You do need to know a few things about it. Don't wear yourself out with it, but
Isn't that when an infant gets this?
both of these are. So intramembranous ossification, you need to know includes bones of the skull and face. And those are going to start out as fibrous connective tissue. So, skull here and face. And why that is important is because when the babies are born, is their whole skull ossified just yet? No. You seen in the video where they were talking about fontanelles. So what are fontanelles?
The little line that base a little bit.
They're what?
The soft spot.
Yeah, soft spots, spaces. So you have sutures, and you can't see them really good on our skeleton, but you have lines, like we're talking about. But these guys have openings. The one on the top here, the frontal fontanelle, looks kind of like a star, and it's shaped like that. And it's filled with cartilage, so it's not bone yet. And then you have a posterior one that's shaped like a star as well, and it's a little smaller, and it closes a little earlier than this one. But both of them will close by the age of 2. So what is the purpose of them? That's one, but early on through birth, what's the purpose of those fontanelles? Yeah, it'll help squeeze that head and pass through that birth canal, particularly the pelvis. So that big head can squeeze, mold, and shape and pass through that pelvis. Because if you've seen brand new babies that were delivered through vaginal, what does their heads look like a lot of times? Yeah.
Like cone heads.
They're all shaped funny, you know, one side may be out further than the other and all of that. But then they'll mold back. They'll mold back to what they should be.
They just go back to normal?
They will.
So is my head like that?
Maybe, if you were born vaginally.